All right. Yep, my microphone's working. Good. So welcome to Kopernik Observatory tonight, everyone. Thank you so much for joining us. Both those on... Oh, there's a ghost. Both those online and here in person. We're so happy to have you. So tonight's program is going to be on spring skies. I do have a little bit of an introduction to go through first, talking about some future Kopernik programs. And maybe we can discuss what you're seeing on this page to YouTube a little bit as well. So first, our website. So Kopernik.org is where you can always learn more about us. Biggest thing we have going right now, in addition to our Friday nights, which are going to continue, unless something dramatic happens, we're going to keep going with the in-person as well as virtual, so a hybrid. Otherwise, though, in addition to Friday nights at 8 p.m., we have our Kopernik Summer Camp registration that's open for grades 2 through 12. So if you know anyone that would like to participate in a camp, they are filling up pretty fast. And we do have some informational forms in the lobby if you'd like to check those out. Nice descriptions of each summer camp there. And it is a paper registration form too, but we recommend you sign up online. That's the best way to figure out what's open, what spots are open, and just secure your spot in the camp. Okay, so those are the summer camps. If we scroll down a bit, you'll always have future programs. Like last week, we had a Family Friday on robotics. So that was March 18th at 8 p.m. We're going to try and do one of those every month. So a Family Friday once per month. That's where it's more activity-oriented rather than presentation. So look out for those this spring too. Currently, our plan is to do one next month on things that glow. And then the month after that in May, we're going to do electric circuits. Okay? So that's Family Friday. This program is full. But it's Girl Power Science. We try and hold a Girl Power twice per year, and it's really to inspire girls to get interested in STEM, science, technology, engineering, and math. So that's grades 3 through 8th. There'll be another opportunity, hopefully, in the fall to participate in that. And if you scroll to the bottom, I want to show you why we don't have the telescopes open tonight. It's really not looking great. We've had bad luck so far during our Fridays. Although the moon has peeked through a couple times. Tonight, I don't think will be one of those nights. Good amount of cloud cover. The white is bad. There's a little bit of teal in here, so maybe there's a chance we'll get something. The problem is there isn't a lot of bright stuff out there right now. And we'll talk about that during the program. So it takes a lot to try and image, a dim object in the sky, or see it with your eye. And if it's cloudy or hazy at all, it's going to impact your visibility even more. So cloud cover is not great. Transparency is really bad. Seeing is okay, but that's only as reliable as having decent cloud cover. So we'll see what happens after the program. Maybe we'll have a chance. But that is where we have our clear sky charts. You can always go to the bottom of the page to see what the conditions in the sky will be like. So you can always click right there. All right. Make sure I'm following my schedule here. Yes. So we saw YouTube here. This is how we're streaming tonight. So what's going on right now is also showing up for those watching on YouTube. Next week, we do have, it's not on our website yet, but it will be posted this weekend most likely. We do have a program planned for 8 p.m. next Friday called An Electric Revolution. And that's going to be just talking about the future of electric vehicles and electrified transportation. So if you'd like to visit us next week too, and maybe the skies are better and more hopeful, we'll have a program on EVs at 8 and then observing afterwards. Okay. So you can always go here for more information. I might revisit this page as we go through the Spring Skies program because we do a lot of observing sessions. you scroll down a bit, we have a playlist observing live streams. And we've observed planets, lunar eclipses, solar eclipses, and we stream that to people back home, especially when it's cloudy here and we visited another location, like during the solar eclipse. That was pretty helpful. So maybe we'll revisit a couple of those later on in the program. But I think now we can get started with spring skies. Okay. Maybe. There it goes. So spring skies. This is not an image we took. We do not have a field of tulips to image that. So that was someone else's photograph. But it's a nice meteor, looks like, in this image. And the nice part about this is that you're starting to get an idea, if you can make out some of the constellations, like Orion here. So my guess is if this is, in fact, a true image of spring skies, this is Orion starting to set in the western sky. So we'll see that as the program carries on here. But spring skies is presented by me. I'm an educator here at Kopernik Observatory, and I am often the one that leads the live stream observing sessions too, so maybe you've caught me on there as well. But today I'm going to deliver this talk on what we can expect this spring. So let's get going. Let's see if this will work. It doesn't. My hope is that if I click here, it'll start working. It does. Okay, cool. So what we're going to talk about in this program, we'll discuss the ABCs of stargazing, how to get you started thinking about the night sky and how it works. Then we'll talk about what we can see in the sky, talking about the International Space Station. That's where the astronauts go. Any human that's been a space explorer, been an astronaut, has flown aboard a space station like this. They have not gone beyond low Earth orbit. So the last time we did that was during the Apollo missions. But possibly here, coming up soon, we have the Artemis missions that will take humans back to the moon and maybe be the gateway to Mars as we head into 2030. Okay, so we'll talk about the ISS. We'll talk about some solar system objects. So planetary conjunctions. There's a lunar eclipse coming up this spring. It's a total one, different from the near total eclipse we had in November. This one is going to, in fact, be a total eclipse. Then we'll get into some deep sky objects. We'll talk about what those are, and this thing called the Messier Marathon. All right. Oh, one more thing. So we'll also mention some observing tools that you can use at home, some that are really accessible, like those that you can run on your smartphone. Okay. So the ABCs of stargazing. So A, that is for the angular size and distance, how we measure where objects are in the sky, how we roughly locate them, and also how we specifically, locate them in the sky. There is a coordinate system at work here too. But let's talk about just rough approximations of how you can tell someone, okay, this thing is about this amount of degrees up in the sky. This can all be done with your hand. As far as the sky is concerned, the average size of a human hand will work fine for this. So if you hold out your pinky, the width of your pinky is about 1 degree in terms of our coordinates in the sky. So that's 1 degree. If you hold out your 3 fingers, that's 5 degrees. Your fist is 10 degrees in width. And then you can do, I don't know, isn't that like hook 'em horns or something? Or Spider-Man, if you want to hold your thumb out. So 15 degrees. And then like the radical dude or telephone, that is 25 degrees. That one's not up there, but that one is 25 across. You can also use the Big Dipper to approximate this. So in the cup, the wide part of the cup of the dipper. I thought there was a laser on this. Isn't that working? Oh, this one. So you can see my little red laser dot here. So 10 degrees in the wide part of the cup. The short side is 5 degrees. From here to here, that's 15. And from the tip of the cup to the longest point of the Big Dipper, that's 25 degrees. So you can also use the dipper. But your hands work really well. Pinky 1, 3 fingers 5, fist 10, 2 fingers out 15. Okay? So, and you can use those in either direction. So let's say you're trying to pinpoint a star, or where a star is relative to each other. So that'd be like with the Big Dipper. So the distance between this star and this star is about 25 degrees. You could tell someone that by measuring it. How far is Jupiter from Saturn in the sky? Again, that's more of like a horizontal direction, so you can measure maybe 15 degrees. But you can also measure from the horizon. So how high is the object up in the sky? Measure from the horizon. You can walk your hand up the sky to measure. And you can do that with any of those formations. So great tool here. And you have it with you at all times. Okay. B is for brightness. Now this one is not really what we call intuitive. It's not what you'd expect. And if you've taken astronomy in college or a high school course in astronomy, you'll know why. The very bright things in the sky are negative numbers. The sun, the brightest object in the sky, it's past negative 25. Negative numbers are bright. We have the moon at around negative 12. Venus around negative 5. Sirius around 2. Vega, the bright star, is at 0. Sirius is the brightest star in the northern hemisphere, but Vega is pretty bright too. The faintest naked eye star, meaning the star you can see, the faintest star you can see with just your eye, that is at around 6 or 7. The brightest quasar, this is way past your ability to see things in the sky with your eye. You need an aided eye with a telescope. Quasars are black holes spitting out radiation. So the brightest quasar is around positive 13, excuse me. And then the faintest objects are way out here. So those would be things like what Hubble can see, the Hubble Space Telescope. So positive numbers are faint, negative numbers are bright. And this is just our magnitude system. We use a scale for brightness. And we might point out a couple of these here, but it's good to know. You know, you have some context for where the moon is. We roughly know how bright the moon is. We've seen it compared to the sun. In the daytime, you can see the moon, right? It's bright enough to get through the daytime sky. Venus is as well. Jupiter, you can see in the daytime with a telescope, all right. It's pretty dim, but you can just about make it out. Even some stars, like if Sirius was out in the daytime, you could see it. It's pretty bright. So it gives you some context. Brightness. It's opposite what you think. Negative numbers are bright, positive are dim. Yes?
Is that a logarithmic scale?
I believe it is, yes. I believe this one is logarithmic.
When you go from, say, -5 to -6, that's 10 times as bright.
Correct, yes. If it was logged, yep. Okay. Oh, keep forgetting I can use this. C is for coordinates. We have 2 coordinate systems we can work with. We have alt-az, altitude and azimuth. So you can see azimuth is your circle on the bottom. It's measured in degrees. So our tool we can use, our tips there, different hand formations to mark out how many degrees in the sky an object is. We can use that. You can see some people are doing that right here, pointing them out. So azimuth is around on the bottom there, and altitude is up in the sky. So between those two, you can mark out coordinates. So this star has an altitude of 50 degrees and azimuth of 150 degrees. And this is based on north, south, east, and west directions. So north is 0, east 90, south 180, west is 270. And then, of course, you don't go all the way around because we can't see the entire sky where we have a planet that we're observing from. So we're from horizon 0 degrees up to 90 degrees at the zenith for altitude. Now, this is great for just kind of pinpointing an object in the sky in a given moment. It's not great for tracking things in the sky, especially in the case of telescopes that use what they call the equatorial grid or the celestial sphere. And I think this is going to be best demonstrated in our program Stellarium. So the equatorial system or the celestial sphere coordinates, that's right ascension and declination. And whereas this one is fixed to the Earth's point of view, so this coordinate system, it's almost like a projection of our latitude and longitude. This one does not move with respect to the stars. It moves with respect to the Earth's rotation. This one, however, does move with respect to the stars. So we'll see that in Stellarium, a program I'm going to introduce to you. So let's have a look at Stellarium, and I should just be able to pull it up right here. Very good. Now I do have to reset it. So Stellarium, in fact, Stellarium is a free piece of software you can download at home. You can get it for Linux, Mac OS, Windows. There's even a web-based version for Chromebooks, or if you want to try it on your smartphone. It is free. It is fantastic. Amateur astronomers across the world use Stellarium for their observing sessions, and it's your own personal planetarium. You can travel through time, thousands of years into the future if you wanted, or into the past to see what the skies looked like. You can see where the planets are going to be. We'll use this a lot during today's program to look at some celestial events coming up. But I'd like to just start by getting us familiar with it. So you can download this at stellarium.org. So this is what it looks like when you download it. You can pan around the sky. If you've ever been in a planetarium before, it's just a 2D screen planetarium. You don't get the whole sphere of a dome to work with. So you just pan around with your mouse and look around and see all the constellations and stars that are out there. You have a media bar to travel through time. There is also a date and time window that lets you select with more specificity. So that's really useful. You can change this what's visible. So if you want to see what dimmer stars are out there, you can adjust that. More stars will pop out. You want to turn down light pollution, or you can even turn off the atmosphere completely. So you can see what the skies look like if we didn't have air. That's a fun experiment to do in here, not one you'd want to try in real life. You can also turn off the ground to see the stuff that the southern hemisphere gets to see. So you can look down here and see what we're missing. Okay. There's also deep sky objects and planets. So you can turn those on and off. So it's very powerful. Right now the constellations are up. We can also draw the labels and the artwork to show you the mythology behind the stories in the sky. This is Greek mythology, Greek and Roman, but there are a lot baked into Stellarium. You can explore many different cultures of stories in the sky. Okay. What's this? Oh, it says it's Crew Dragon 3. I don't know if that's right, but interesting. I thought it was the ISS because it is supposed to be rising soon. So that's Stellarium. I wanted to show you the grids. Oh, that's equatorial. Let's look at the azimuthal grid. That first one I showed you. Let's not have both on at the same time. So now we can see the zenith is right up top, right? And so that's from 0, your horizon, to 90 degrees up. Or we can go from north for your azimuth, which is 0 degrees, to east, 90, south, 180, west, 270, and back around to north. So if you wanted to figure out where, where's Mizar here? I always forget. Mizar. Where Mizar is in the sky, you can measure it by using our grid, our azimuthal grid. Now you'll see, I'll show you the other one in just a second. You'll see if I travel through time here, it doesn't move. The grid moves with the Earth. It does not move with the stars here. Or rather, it moves with your perspective on the Earth. Your view, your vantage point, I should say. Make that distinction. So you can see the stars are moving through it, even just through the course of a night. This is not ideal to map out a very specific location of a star in the sky. So instead, if we go back to current time again, we can use the equatorial grid. And do you see how the zenith of the equatorial or the celestial sphere changed here? Our perspective on it changed. You have now the North Star as the top of our grid. This is if you took the latitude and longitude of planet Earth. Sorry, I flipped that around earlier. This is if you took the latitude and longitude of planet Earth and pushed it out. So the North Pole stretches way out in the sky here, and if you measure from horizon to North Star, you get 42 degrees, which is our latitude. That's pretty handy. So that's Polaris right there at the tail end of Ursa Minor, the North Star. This is the Little Dipper or the Little Bear. That's what Ursa Minor directly translates to. And you can see also the North Star doesn't match up perfectly with the North Pole. So it actually does swivel around it a little bit over time, but we can use it as almost a due North Star. Now, if we travel through time again like we did before, notice the stars are synced up to that grid. So as the Earth rotates around, the sky appears to move, but this grid stays fixed to the stars. Because if you want to locate Arcturus, let's pause it there. Arcturus is a nice bright star. It has very specific coordinates in, you can see them, well, those in the front will be able to read them, maybe. The RA, the right ascension and declination coordinates for this grid. We can use those to locate these objects, and this is usually the coordinate system that telescopes use, right ascension and declination. Okay, so we'll come back to stellarium a little bit later, but I wanted to get you at least somewhat familiar with that grid. We'll turn it off for now because we won't necessarily need it when we come back. Alright, so we looked at stellarium, we sort of introduced that. Again. There we go. So what can we see in the sky? So I mentioned the International Space Station is flying over tonight. Now it's too cloudy to witness it, unfortunately. But you can see the International Space Station because of how large it is. It's the size of a football field. Most of that is taken up by the solar panels. And they're very reflective, as you might expect. So it appears as a bright moving star. It's not no blinking lights or anything. All of the light that's coming off of it is coming from the sun. So it's a nice steady light across the sky. And it moves pretty quick because it is moving fast. It orbits 250 miles above the Earth. This is what we call low Earth orbit. it's actually still in a portion of the atmosphere, so it does slow down over time, and they have to boost it. So it orbits the Earth every 90 minutes at a speed of 17,500 miles per hour. So the best comparison here, because that's just a big number, what does that mean? I haven't traveled that fast. You could travel from New York City to Los Angeles in less than 9 minutes at that speed. So this thing is booking it. And because of that, we get a lot of opportunities to see the space station. It's not always visible at your location, but there are a ton of opportunities during the year to spot it. Tonight is just one example, but we're sort of in the phase where it's passing us a fair bit. So we'll have more chances in the spring here. So this was tonight's ISS flyover. We have northwest here and northeast. So this was its path, this dark line here. Pretty low flying. That's also why we probably would have spotted it just above our trees, but we do have a tree line out in the western sky there. So usually our best opportunity is when it's flying, maybe 30 to 40 degrees or higher. So that's a pretty low flying path. This website, though, amongst many other resources for finding the ISS, this one's called Heavens Above, though. We can use this, I have it loaded up here, to figure out when the ISS will pass overhead in our area. So you put your area up in here, and then you can see a bunch of dates show up. The magnitude, again, negative numbers are good, so tonight's pass at about 8:26 was a negative 1.2. That would have been pretty bright at its brightest point. But at its highest point, it only reached 16 degrees above the horizon. Like I said, that's pretty low. So it was a visible pass, though, and if we click on it, we get an ad. If we click on it, you get a map, that map I showed you in the presentation, showing you the exact path across the sky relative to the constellations. Really useful tool, this website, amongst others. Like I said, even Stellarium does model the ISS flying across the sky, so you could use Stellarium as well. This is just a nice list format to see when it's coming up easily, rather than hunting it down in Stellarium. So you can see we have a ton of opportunities. So if we have clear skies in the next week or so, there's even some better ones than tonight. Negative 3.3. Ooh, that's a 53-degree flyover. 9:20. Ooh, April Fools. Oh wait, that's our next Friday. Maybe we will get a chance to observe that one up at Kopernik if it's clear. Cool. So, oh yes.
When do you talk to them through the ham radios?
Oh yeah, that's a good question. We actually do have a plan this summer, and I think we still don't have an exact date for it, but the Welcome Aboard the International Space Station camp, that's probably filling up pretty quick because it's very popular. But that's grades 5 and 6, and that gives students the opportunity to talk to the astronauts on board the International Space Station. It's really cool, and we do stream out the video, so everyone gets the chance to sort of have fun and participate in it. And it's always a huge event for us, and it's very scheduled though, because we're using ham radio, so we can only communicate with it as it's flying overhead, and so we're limited on that front. It flies across the sky pretty fast. If you look at these times here, tonight it would have started. It started 8:26. Highest point was 2 minutes later, and it ended at 8:30. Almost 8:31. So just a few minutes of contact there. Now, ideally, you sync this one up with a high flyover so you get more opportunity. But it is very scheduled, and on top of that, the astronauts are just very scheduled too. So we have to take their time into account as well. All set up through NASA. It's very cool. All right. So that's Heavens Above. You can go there to learn more. It's not just ISS passes either. If we go to the main page, there are Starlink passes too. If you want to try and spot the string of satellites across the sky, that's there as well. Hubble Space Telescope. There's several popular satellites to spot on this page. Okay. Let's go back in here. Now, I did want to just briefly mention the astronauts that are currently on board. It's packed up there right now. We're kind of in a transition period from expedition, I think it's 66 to 67. So there's more astronauts than usual on the ISS right now. So it's I'm sure pretty cozy. It's not a huge craft to begin with. It's but you know there's evidently enough room to fit 10 people. So there's so many. I'm not gonna struggle with the names today. But there they are. Some. Let's see. Do I have? There we go. So some are from NASA, some are from the ESA, and some are from Roscosmos. So one of the Soyuz rockets just launched up there recently, so that's why there's quite a few Roscosmos astronauts or cosmonauts there. So it is an international effort, and it continues to be. And it's international efforts like this are really important. You know, it's in some ways helps to be a peacekeeping effort where possible. So really, really brilliant work they continue to do on the International Space Station. Okay. Just realizing this is a little bit... Okay. So some solar system objects now that we're going to get into. And I have a lot of asterisks around these. So the moon, we get to see go through its phases just about once a month. So we get from new moon to full moon, back to new moon. Takes about a month. Now this moon here is not in a phase, it's a full moon. This is the start of an eclipse there. We'll talk more about that. Now, I learned this from one of the presenters we've had up here in the past. She pronounces it Uranus, so that's how I'm going to pronounce it today. I like that. That's the Greek pronunciation of Uranus. It has an asterisk because it's very dim. It is visible in a telescope, and it's out right now. You could try and find it. You would see a little bit of a teal color through our telescopes, but really not much else. You'd be able to tell it's not a star. Stars are point lights. So this has more of a disk feature to it. But it's too dim to really make out any detail. It's just so far away. This is why it took so long to discover this planet. A couple more here. We have Mars, Venus, Saturn, and Jupiter. I had to remind myself with 2 asterisks for these because they are morning objects. Now, usually with spring skies, we try and focus more on what's out at a convenient time. Because the later you stay up, you start to get summer objects. When we say spring, summer, winter, fall, it's kind of relative to how late you're willing to stay up. Now, some stuff won't be visible during, in the summertime. Orion isn't really visible in the early summer because it's behind the sun. So there's some instances like that, but otherwise, you have some opportunity to see. If you stay up late enough now, you might start to see some summer objects rise in the early morning. And that's the case for the planets, a lot of the planets right now. But there's so many cool events happening with them this spring that I want to talk about those morning objects. Okay? Oh, yes, Ben. Oh, this one here? So, okay, yeah, let me explain these. Thank you. So we talked about the moon. This was Saturn. That was an image actually. Well, these two are stacked images. This is when you take a video, get a bunch of frames of a planetary image, and then stack them to get as much detail out of it as you can. So this one actually came from an iPhone, which is kind of cool. You know, you have to use a telescope, of course. This was through our large, 6-inch refractor. But you hook an iPhone up to it, or a smartphone, and take a video, and you can stack an image. Pretty cool. You can see the Cassini gap, the Cassini division in the rings. This is a really good night to observe Saturn. This down here is Mars. And Mars is, especially in our area, even when it's closest to us during close approach, it can be a real challenge to get some detail from it. We do see a feature here on Mars. This is Syrtis Major. It's a nice dark feature on the planet. You also see the south pole of Mars. See that little white spot? So that is the south pole of Mars. It has polar ice caps. Now, the south pole of Mars was pretty small because it's the summertime in that region. Mars does go through seasons, summer, winter. So it was pretty small. It does grow and shrink with the seasons. So we were able to pull some details here at Kopernik with just our 6-inch. Both of these were through the 6-inch refractor. It's a great scope for planets. This was through, I think this one was through the 6-inch as well. This is Venus. The inner planets go through phases. So, because we're looking inwards at them, right? So sometimes we can be looking on their darker sides. So in this case, this is a crescent Venus. You can have a gibbous Venus. You can have a half Venus. You can have a nearly full Venus. So that's the case for Mercury too. So good. There's Venus, and then the one that's not up here is Jupiter. Jupiter will be visible as we head later into the spring. So I'll jump into Stellarium to show you these. Is it next? No, not next. First we do the lunar eclipse. So the total lunar eclipse preview. This image was from November 19th, just this last year, 2021, and it was a almost total eclipse. There was just a sliver of partial lunar eclipse left. It was so close. And that meant that it was just over here where it's much brighter. That meant we were able to pull a lot more detail out of it. And this image is kind of cool because you're getting the bright side of the lunar eclipse, where you're still getting a lot of sunlight on it. Then you're getting the Earth in shadow. And this red color that gets projected onto the moon, when during total eclipses it's fully red. That's kind of, we call it a blood moon. All that is if you think of a sunset, as the sun sets and gets closer to the horizon, the sky starts to turn pink and red, right? That's all that's going on here. The sun is passing through the Earth's atmosphere at that more horizontal angle, right? More direct angle, and then it gets projected onto the moon, and it shows up as red. So that is an example of a partial eclipse. We're excited to see the total eclipse. Let's go into a little bit of detail about that. So it's going to be May 15th to 16th. We will transition into the next day during this event, starting at 9:32 p.m. We have 7 stages of a total lunar eclipse, and I've mapped out the times here for you for each stage. 9:32 p.m. will be the penumbral eclipse. Let me bring up that image here. There's two major shadows that can occur on the moon during these eclipses. So we have the sun, the Earth, and the moon here. They're all lined up. This doesn't always happen. But it's when the moon enters the Earth's shadow is when we get a total lunar eclipse. Solar eclipses are, of course, when the moon is on the other side in between the Earth and the sun. And it's lined up just right so that the moon covers the sun. Okay. So the shadow, though, we have a penumbra. You can think of that as, if we look around at the shadows around the room, you can see there's some there's a harsh shadow, right? And there's a faint, diffuse shadow around it. That's basically how we can think of umbra. and penumbra. Penumbra really doesn't have much impact on the brightness. Well, to your eye, it doesn't have much impact on the brightness of the moon. The umbra is where we really start to notice it, where we start to get that red color. So there's the times, the partial eclipse where you will notice the shadow. That's when it enters the umbra at 10:27. The total eclipse starts at 11:30 p.m. We get maximum at midnight, and if you want to carry all the way through, you'll only be staying up until about 3 a.m. It's really not that bad compared to the partial lunar eclipse in November. That one took us it was started around 1 a.m. and ended around 6 a.m. So that's why we streamed it instead of holding an event, because we figured most people would just want to watch from home and probably just watch the recording more than anything else. So that is the total eclipse. If you want to learn more, you can go to timeanddate.com. That is a great website to visit for astronomical events like this. Again, I will break from the slideshow here to show you at least a couple of frames from that live stream. So usually with our live streams, we have it broken down into segments and chapters. Oh, look at an ad. We almost got, I thought I was going to play with that one. So there we go. Skippable ads are the best. Very good. So we had a pre-show, and then we got into the penumbral eclipse, and then the partial just began, and then guess what? Clouds. Of course. So we had like an hour and a half of cloud cover conversations until the clouds cleared and we started to get the partial eclipse back again. This was just after maximum, so this is still pretty bright here. This is a good amount of brightness on the moon, and it is growing. So this real sliver was just a little, during maximum, was just a little faint bit at the very edge here. So this is still pretty big, but we were happy the skies cleared all the same. And you can see that nice red color show up, and we got to watch it. If you watch the thumbnail there, you get a little time lapse. You can see the light grow across. So this is a lunar eclipse, and this is what we're really excited to observe come May 15th. And assuming that we are getting like a nice forecast for this event, we will probably hold something because it's a pretty convenient time to bring people up to Kopernik. I think a lot of people will want to observe. So we'll be open, and we'll also be streaming. So we'll be doing a hybrid thing again. Okay. We did. So this is a really cool image that was an actual astronomy picture of the day by Lishan Wang. And it's the different stages of the lunar eclipse lined up so that you can see the Earth's shadow. See how big it is? So that really gives you an idea of how this is working. So, and why total eclipses last so much longer than, why lunar eclipses last so much longer than solar eclipses. Total solar eclipses, you only have like a minute to a couple minutes to really appreciate totality, because the moon is about the same size as the sun. It's about half a degree across in the sky. So when it's passing over, you just have that brief moment, and that's really unique in the solar system, by the way. It's pretty cool that we have that. And then you get the nice atmosphere of the sun, the corona surrounding it. So totality of the solar eclipse is brilliant, but it doesn't last long. You can see why total eclipses last a lot longer, because you have that whole shadow of the Earth for the moon to pass through. So lots of opportunity to appreciate totality. Okay. So we're going to do another stellarium break here with planetary stuff. And let's have a look first at the eclipse. So we're going to go back to current time. And this will show you again. I just like to show you how Stellarium operates on top of it all. So you go over into the clock, and you get your date and time. So we need to go to May 15th. So we'll go to May. We'll go back to 15. And we can see the moon. So we're at 8 o'clock now. Eclipse starts at 9:32, right? So is that a full moon? I'd say so. So we have a full moon. And are we in, yep, we're in the eastern sky, so it's going to be rising up here. So let's click down to that, and there's 9:30, and the eclipse has started. And you start to see, that even in Stellarium, it starts to dim a little bit during the penumbral eclipse, and there is the partial, where we actually get the shadow. You can simulate an eclipse in Stellarium. It's really cool. So you get, this is the actual shadow, the umbra of the Earth. We'll carry on here. You can see it, that shadow grow and grow. And there is totality. And it even shows you the red moon. Okay, and you can now see its location in the sky too. If you zoom out a bit, we're already almost due south now. It's going to move with the sky, of course. Oh, and look at that. Oh, I'm already thinking this is going to be a really cool shot to try and get totality mixed in with the Milky Way. If you could image that, that'd be so cool. Because the Milky Way is right here. And you can see the Milky Way nice and bright at Kopernik. So you have some really cool objects to photograph in addition to totality from the moon. So you can simulate a lunar eclipse. Again, that's May 15th, a little bit later in the spring. Now let's go back to something happening in the next few days. So back to current time, March 25th. We're going to skip ahead a few days, and this is where we're going to, I'll have to ask you if you want to observe these events. You got to be a night owl or an early bird. We're going into the early morning hours now, but they're cool events. And they're unique to the spring right now. Okay, so 28th. Actually, let's go to the 27th because we're going to have to go into the 28th, the morning of. And if we look into the eastern sky, yep, there we go. At around 5:50, you have a really cool planetary triangle. You have Venus, Saturn, and Mars forming a trio, and in addition, you have the moon, a nice crescent, waning crescent moon. So this isn't too bad. It's approaching 6 o'clock. The problem is they are still pretty close to the sun right now. So you have to get out there and get a nice clear horizon to observe this event. But you'll get a planetary trio of Venus, Saturn, and Mars, and you'll get the moon. That is March 28th at around 5:50 a.m. will be your best opportunity. March 28th. Okay? And next one up, we have a planetary conjunction. So this is April 4th at 5:30. Get a little bit further above the horizon here. Around 5:30, do you see these two dots here are super close? So if we click on one and zoom in, you'll see that Mars and Saturn really close together. And by the way, you can zoom in on planets too in Stellarium. Saturn here, zoom in on that as well. There's the rings of Saturn. And its moons, yeah, good observation. So with a pair of binoculars or a nice wide field telescope, you will probably be able to get both of those in the field of view. Now, it's not going, Mars especially is not quite close enough yet to make out much detail. It will get closer. Close approaches in December this year. So it's closer than usual, but it's still not the closest. Saturn, however, will have a disk shape to it because of those rings. So you'll see Saturn's rings. You might be able to make out some of the moons in your field of view. So that'll be a pretty neat event because you can observe both Mars and Saturn in the same optical instrument. So holding up binoculars or using a wide field scope. Mars will be red. So that's probably the coolest feature you'll see as you observe the two planets. And also, it's just kind of cool to, in the same field of view, just to see the two, even if you're not getting a lot of detail. Okay. Now, you're also going to start to notice something here. Venus, Saturn, Mars, they're less a triangle and starting to form more of a line. Let's see what happens. Let's keep going through the days. Oh, someone's joined the party. All right. Next planetary event. So we had the conjunction on April 4th. We had the planetary triangle just a few days from now on March 28th. Here at around 5:30, 5:20, I think you might have, it'll be a little darker. You might have more success around 5:20. You can see we're really fighting the sun here in the brightness from the sun. But we can see that this is a nice line of planets across the sky. And they follow an imaginary line that's called the ecliptic, or the zodiac. I can bring that up for you with sky and viewing. Let's see. Which one is it? That one. So, you see how they all follow along that line? That ecliptic line represents the plane of our solar system. So all the objects in the solar system, all the major planetary objects, including the moon too, they're going to follow along this plane. Because when a solar system forms, it forms with an accretion disk. So you have the sun at the center, and then you have this disk of material that forms the planets. And that's not unique to our solar system. That's how solar systems form. So you got all 4 planets there, and if I recall, yeah, you have the moon too on top of it all. I think this is a waning gibbous. Yes, waning gibbous. So you have a waning gibbous moon following that ecliptic along with Saturn, Mars, Venus, and Jupiter. So if you really wanted to, you could break out a telescope and observe each one of those right in a row. And it'd also be another neat picture to image there too, with the moon included. If you can get a wide enough shot, really cool line of planets, planetary alignment. That is April 20th at around 5:20 a.m. And I forgot to mention one more thing about Mars and Saturn. Mars and Saturn, during that conjunction, are going to be about the same brightness, the same magnitude. So that'll be kind of another neat addition to that event. They'll be very, very close in brightness. So my last two more planetary conjunctions for you. April 30th, these two are going to be even closer than Saturn and Mars. So Venus and Jupiter. Venus is a gibbous. See there? Almost a half Venus, but a gibbous. And then Jupiter with its moons. They'll be nice and close. You'll see Jupiter's moons in a wide field set of binoculars or telescope, and you'll see Venus as not quite a circle. You'll see it as a gibbous. Okay, and the last one for you is May 28th at 3:30 a.m. Back. So I'm not sure if this is better or worse, 3:30 a.m. But this is where you have Jupiter and Mars. These are further apart, but again, through something really wide field, taking a good chunk of the sky to observe it. You might be able to make out the moons of Jupiter, and Mars will be a little bit closer too, so you might notice it's a bit brighter. Okay. So that is planetary events happening this spring. Really cool ones. The ones I'm probably going to try and make an effort to observe are the Mars-Saturn conjunction and that alignment of the planets. And maybe try the planetary triangle too. That might look pretty neat. Okay. Alrighty, so click here. Star stuff. So the Milky Way will get better as spring goes on and as we head towards the summer. Early summer is when it really starts to get good. This is a image of the Milky Way in the summertime. And you do start to get this core. If you stay up late enough, you get to get that core of the Milky Way. You can do some cool imaging like this, where you get the dark nebula, the dust lanes of the Milky Way, and the bright core where our supermassive black hole lives. This is right in the constellation Sagittarius. Sagittarius is the teapot, and the nozzle of the teapot is sort of pouring out the Milky Way. So that's a great one. I think this is Jupiter and this is Saturn. They won't be like that in the spring here, but that was when this image was taken. I think 2 years ago. That's where they were. Okay, some nebulae that are on the way out. We have the Orion Nebula. The Orion Nebula is a fantastic object to observe with your eye and take a picture with a camera. Really big stellar factory. This is where stars are born, right in the core here. It's sort of a reverse funnel in shape, so they come funneling out to make their own solar systems, start spreading out into space. It's not the only stellar factory in our galaxy. There's many of them, but this is one's very close to us. And we also call that M42. So very quickly, I want to show you some stars we have in Stellarium, because I have not talked about those yet. We're really pushing towards the end game now. I think maybe 15 more minutes or so until we can do a Q&A session. Or just question and answer. If you have questions, I'll answer them. Good question. All right. So this is the sky as it is right now, 9:04 tonight, March 25th. And we can see some of the constellations that are out. Orion is really a good winter constellation. That's nice and high up in the sky, just after sunset. You can see now it's more westward. Constellations that are closer to the west are going to be setting earlier and earlier as we head into the spring. Constellations that are in the eastern part of the sky are going to be rising earlier and earlier as we head into spring. So you get an idea of how this this is because we're orbiting around the sun. Instead of rotation, it has to do with orbit and our position looking outward into our celestial sphere. So Virgo, in the eastern sky here, is an example of a spring constellation. It's rising up in the east in the evening to early nighttime, and that means it's a spring, an example of a spring constellation. Leo as well is a spring constellation. Some people consider Gemini, and Gemini is cool because they really do look like two stick figures in the sky, with two bright heads here, Castor and Pollux. Those are the stars' names. And Sirius is an example of a winter constellation that's going to be on its way out here too. It really hugs the horizon. Sirius is Canis Major is the constellation. Sirius is the brightest star in the sky right now. So if you want to observe that bright star, you can go out and see Sirius over the next month or so. But if you want to see the Orion Nebula, this is where it's located in the constellation Orion. We can zoom in and see that deep sky object that we saw as an image before in our slideshow. So this is going to be visible for a little while yet, but if we travel through time, day by day, so we're not hour by hour, we're day by day. Do you see how it's getting lower and lower? This is April 5th. It's already really low in the sky. Keep going. And by May, we really lose it. It's getting very close to the sun here. So you're not going to get the chance to observe that very easily. Okay, back to current time. And you got a sense of how the other objects surrounding Orion are also going to be setting, like Canis Major there was setting earlier and earlier. So those are your winter constellations. Those are on the way out. The ones that are on the way in are Virgo, Bootes, Corona Borealis, Leo's coming up. If we advance even further, we have Serpens, Libra, and then this is going hour by hour, by the way. Scorpius and Sagittarius are going to be the sign that summer is getting closer and closer when they rise early and earlier. And like I said, Sagittarius points, the nozzle of the teapot, points right into the Milky Way's core. It's like it's pouring out the Milky Way galaxy. Okay, so those are some constellations we have to work with. Some are on the way out, some are on the way in, and some are pointing to summer. Okay. Now, the spring is what's known as galaxy season. This is the time to observe some of the deep sky objects that are out there, especially galaxies, because a lot of them are nice and high up in the sky. Here's an example. In the constellation Virgo, you have the Virgo cluster. This was an image taken, not at Kopernik. We took this at Cherry Springs. Cherry Springs is a really dark sky area, even darker than here. It's down in Pennsylvania, near Coudersport, Pennsylvania. Really nice place to go. It's a state park. Super dark skies. And this was one of the images taken there. Every little fuzzy thing in this image, even the dim things in the background, down here, every single little fuzz is a galaxy. This is something that you can see with your eye, so at least the brighter ones. And then when you hook up a camera, you start to pick up some of these dimmer ones. It's like that, an observable version with your eye of that Hubble Ultra Deep Field. If you've seen that image from Hubble, where they just pointed it to a super dark area of the sky, took a long exposure image, they saw thousands upon thousands of galaxies in that image. You can just count them and you'll lose count. You got to count them again. This is kind of like that. It's a cluster, an example of a galactic cluster that you can view with your eye. The Virgo cluster. Okay? Here's another galaxy that's part of galaxy season. The Whirlpool Galaxy. This is one of my favorites. M51. So you have a big galaxy here, and you have a small galaxy being eaten up by it. So this is a galactic collision in action. Now these things are huge, so you're not going to see any movement from them. But slowly over time, these two galaxies dance through the ages as this one gets absorbed. This is kind of a hint at what our Milky Way and Andromeda will do in about 5 billion years. They'll start to collide like this. That's M51. It doesn't really come out on this screen. I see it better up here. But you might be able to see some weird wispy things here. A bunch of satellites photobombed my image. So you can barely make them out up there, but there's little streaks. I'm not sure what satellites they were. Maybe Starlink. So the Pinwheel Galaxy, M101. This is another favorite of mine. Because, again, like Whirlpool, it looks like a pinwheel, right? It really does look like what they're describing here. So you can see the material really stretches out, though. If you look carefully, it goes way out here from the galaxy. These big arms. Okay, pinwheel. This is Bode's Galaxy, M81. I like this one too. It has these nice spiky arms on the top and bottom. Nice bright core. These are all spiral galaxies, like our Milky Way and Andromeda. Then we have the Cigar Galaxy. This is an irregular galaxy, not a spiral. It has this nice dark band in it. M82. These are all visible in the springtime here. So I want to show you where some of those are located and the reason why. One particular constellation I have not pointed out yet is the Big Dipper, or Ursa Major, the Big Bear. Do you see the bear if I put the artwork on? There's the big bear with its big tail. So we have the cup of the Big Dipper, we have the handle. As we head into spring, do you see how it climbs up the sky? Gets higher and higher and higher. That is really good. Because there are a ton of galaxies around the Big Dipper. One of them being M51, the Whirlpool. The higher deep sky objects get, the more visible they become. So it's to our advantage to observe these dark objects in the springtime. They'll be visible other times of year, but they're not going to ever be as good when they're hugging the horizon, because you're looking through so much atmosphere, it gets really hazy. Higher up, you're looking through less atmosphere. At zenith, it's even better. So this is the time to observe those galaxies that are in this area. So if we zoom in, let's see if we can find a few. There's Whirlpool. So you can see it's actually not too hard to find Whirlpool because it kind of forms a triangle between Mizar, Alkaid, and Whirlpool. You can zoom in, and there it is, the Whirlpool Galaxy, right next to the tail of the Big Dipper. And to the left-hand side over here, moving more northward, we have the Pinwheel Galaxy. Isn't that cool how they're almost like equidistant from the tail? So you could bounce right between those, no problem. Image the Whirlpool Galaxy for a while, or observe it with your eye for a bit, and then bounce over to the Pinwheel, nice and bright in the dark skies of the spring, where they're pointed right up. Look at this, there's a Sunflower Galaxy. That one I don't have an image for to show you, but, well, one that we've taken here. But here it is in Stellarium, Sunflower Galaxy. Another one, Croc's Eye Galaxy. This one I haven't observed at all. Well, that's pretty cool, though. I might have to go hunting for it. M106. That's another important crowbar. I'm trying to remember. Let's see. Let's put in. Oh, I already forgot. I gotta remember the Messier number because I forgot it in my head. M101, M81 is where we want to go. There it is. Further up along the Big Dipper towards the head of the bear. There's the head of the bear. Bode's Galaxy, M81. With those nice spiky spirals. And the cool part about Bode's Galaxy is Cigar Galaxy, M82, is right next to it. Well, there you go. Bounce between the two. In fact, you can, in a nice wide field, you can get both of these in the same telescope or camera. All right. They're just speckled, all galaxies everywhere around the Big Dipper. So it's a great time to go hunting. And a lot of these can be bright enough where some binoculars will do what you need them to do. You'll at least see them as these little, smudgy, ghostly objects in the sky with binoculars if you don't have a telescope. But of course, the bigger the scope, the better. The more you're going to be able to pull, more detail you'll be able to pull out of it. So, galaxy season. Where's Virgo here? Let's see if we can find the Virgo cluster. So, we're around there. Oh, here we go. Do you see how many galaxies are showing up now? Look at this. It's crazy. Virgo cluster. Galaxies speckled everywhere. M88, M91. Almost everywhere you look near Virgo, there's a galaxy. And Virgo's a spring constellation, so this is the best time to observe those. Go galaxy hunting. Now, the last topic I'll focus on is this idea of a Messier Marathon. Do you remember all those names for, like, the Whirlpool Galaxy was M51, Orion Nebula M42. That M stands for Messier. The Messier catalog is 110 deep sky objects. They were cataloged by Charles Messier. He was a French astronomer from the 18th to 19th century. He was a comet hunter. This is his catalog of not comets. He didn't know what they were. To be fair, it was the 18th and 19th century. They didn't know what a galaxy was. So this is his catalog of, okay, this is really interesting, but I have no clue what it is really. So, not a comet. I'm hunting for comets today. Now, on April 1st and 2nd, that weekend, coming up next week, you have the chance to observe every single one of the Messier objects in that catalog. That catalog includes star clusters, nebulae, and galaxies. So there's a ton of variety in there. It's not just galaxies. And like I said, it's April 2nd, which is nice and close to the new moon. Actual new moon is April 1st, so you have that opportunity Friday evening into Saturday morning, or Saturday evening into Sunday morning. And really, if you could try Sunday evening into Monday morning too. The moon probably won't get in your way too bad. That's the concern, though, is you gotta fight the moon here. Because technically you could have done this all through March if the moon wasn't in our way. But the thing is, these Messier objects are spread throughout the entire night sky. You have to go start as soon as it gets dark to and end when it brightens up. The last one is pretty close to the sun, so you gotta make sure you look for that horizon hugger. I think it's M33. It's gonna be pretty close. So there is a website called the Messier Marathon. You can just do a Google search, and it should come up. It gives you I should show you. It gives you a rundown. So the Messier Marathon search sequence list with icons. So it gives you little images of what you're looking for. And this is the order that you should go in when you're hunting for the catalog. Because these objects here are going to set early. The ones at the bottom rise late or early in the morning, if you want to think about it that way. But they're the last ones you'll get the chance to observe. So you can see there's a bunch of variety, though. Galaxies, star clusters, nebulae, lots to see. So things like the Orion Nebula, M42, that's going to set pretty early in the evening. So you got to observe that early, as well as the Andromeda Galaxy. M31 sets pretty early. So you got to get ahead. And you're also not doing this to image, you're doing this to observe, just for the fun of it. If you try and image everything, you run out of time and run out of, the sky beats you. So it's a race. It really is a marathon. Now, I've never done this, but some of our astronomical society, they have gone through a Messier Marathon, and I would like to do it someday. We'll see if I have a moment coming up here next week to try this out, because it does sound quite fun. So I wanted to, since I just started learning about it, I wanted to bring it up in our Spring Skies topic. you can do a Messier Marathon. And now I believe we're just about wrapped up here. The last thing I have for you are some tools. So we've talked a lot about Stellarium. We do have Stellarium set up in the computer lab. If you'd like to try it out today, you're welcome to head in there after the program, and we can help you learn how to use it. But stellarium.org is where you go to learn more and to download. Okay, Stellarium. There's other stargazing apps, though, that you can have on you all the time, just with your smartphone. These are just a few. Starwalk, Sky Guide. There's free versions of those that you can try out. I think there is in-app purchases, so you buy more objects like satellites and things to add to your sky. But otherwise, a lot of the main objects are free. And Sky Safari, I think, that's pay it one time and then you have it forever. So that's nice. Not really in-app purchases on this one. It is more professional software, though. So this is great for if you want to control your telescope. If you want to plan out an observing session like the Messier Marathon, Sky Safari is the way to go. A little bit pricier, but powerful software. So those are some apps that are on both Android and iOS. And don't forget that your smartphone is pretty powerful. I always like to add this bit. Nowadays, you can get some pretty cool images with just your smartphone. There's an image of the moon. Can you believe that somehow we have a camera that's that small that can get enough resolution to get detail on the moon? 10 years ago? No. That would not have been possible. So really cool technology that it has to do with machine learning and better optics and sensor design. They work in tandem to get images like this now. Now, starry objects in the sky depends on the camera. This was with night mode on an iPhone. It really likes to muddy the Milky Way compared to that image we saw earlier. But you can see the Milky Way. That's pretty cool. And you can see stars as point lights in the sky. And you can see the constellations. Down here, you can see Sagittarius. Right in the core of the Milky Way like we talked about. So, your smartphone with that night mode feature for stars, and you using the highest magnification lens you have for things like the moon, can be really useful if you want to just try out some astro imaging. Nowadays, just about anyone can image the skies with their camera. So use that tool you have in your pocket. I think that's the last one. Oh, yes, of course. I wish you clear skies, too. I wish we had clear skies tonight. But coming up, especially with all these events going on, hopefully you have clear skies in your area, and you get the chance to observe some of these events. But with that said, that wraps up the Spring Skies program for tonight. I am happy to take any questions at this point. Yes? Nope, they're going to be all set up for you to try out Stellarium. Yep. So you can go ahead and try that out in our computer lab. Very good. Yes.
So for the equatorial grid system for the skies, does that move as the Earth's axis precesses over thousands of years? So you would scan ahead with that axis going?
I'm not 100% sure if Stellarium models that. I think it might, though. I think that's baked in, so let's find out. So what he's mentioning is kind of, we touched on it when we talked about the North Star. That's the wrong one. That's azimuthal. We're going to go to equatorial, and we'll go to the North Star because this is the best example of it. We talked about how the North Star is not perfectly lined up with our the North Pole of our celestial sphere, or the actual North Pole axis of the Earth that points into that sphere. So again, the way we're thinking about this, if you took the spinning Earth, right, it's spinning around a point, the axis. This is the north axis. That axis points right in to that part of the sphere in the sky. Polaris is close enough right now that we can use it as a North Star. It won't always be that way, and it hasn't always been that way. The southern hemisphere does not have a good South Star right now because they don't have a good star lined up with its southern pole. So if we travel by years, let's go to the year 3000. Oh, that's 300, but the point is made. You can see Polaris is way down here. It's north enough, but if you measured Polaris in the year 300 in this area and you tried to use it to determine your latitude, you'd be significantly off. It wouldn't be as effective because it's not close enough to that pole, so you couldn't measure your latitude properly. It is pointing northish right now at this hour, but you'll see if we rotate the sky, there it's more north-northeast. It just so happened that we were at the right time where it was due north. You can see it's rotating, right? Okay, now let's go to the year 3000. We've moved off compared to where we were before, right? Further up. Year 5000. Oh, 500, sorry. 5000. Whoa, now we're really moving off course here. 26,000. Okay. 26,000. There we go. Now we're going to get... Now our stars are warped on top of it all. Because the stars are going to move over thousands and thousands of years. So our dipper is... It's some other utensil now. And you can see the North Star veered off. So this is modeling the precession of the Earth. Our axis won't always point into the North Star because if you ever worked with a gyroscope before or a spinning top, you've tried that. After a while, as it starts slowing down, it does this, right? The Earth is doing that over thousands and thousands of years. Its axis points in different directions in the sky. Great question. Thank you. Any other thoughts? Yes?
You mentioned how the planets kind of line up along the ecliptic because of the way that solar systems and galaxies form from accretion disks.
Mm-hmm.
And I was wondering if you knew, why do galaxies form from accretion disks? Why not a more spherical shape, for example?
That is a good question, and I used to know the answer, but I don't off the top of my head. I did learn it in astronomy, I think, back in the day. But
same reason that when you take the ball and throw it in the air, it forms a pizza crust.
Oh, there you go. Yes, you spark angular momentum. Yes. Thank you so much. It does have to do with general physics, the basic physics problems that you can solve in class. It's very similar, even on that large solar system scale, even on the galactic scale to some degree. Okay. Any others? All right. Well, thank you again for joining me during the Spring Skies program. We'll check to see if the skies are clear. If they are, we're going to try and get something. So I'll make an announcement out there. Last thing, on the back table, next to the garbage can there, to the right of it, there is a star map for March. You are welcome to pick one of those up on the way out if you like. So you can see, it's just, it does show the planets on it too, because it's unique for March. So check that out, bring that home, and observe the sky. Thank you, everyone. And thank you to those that tuned in on the live stream. We will see you next time.